Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Writing Algebraic Equations. And you can see at the top I have in the box the key to success. We're going to read the entire problem, then we're going to do what is called define the variable. Then we're going to go back and we're going to translate the first sentence, and then if there's a second sentence to translate, we'll translate that. If there's a third sentence to translate, we'll translate that, and so on and so on and so on. And when I say translate, I am referring to taking the words and writing what they mean mathematically. So we're kind of treating it like a foreign language, going from English to math. Now, what do I mean by define the variable? Well, follow along. To define a variable means that we're going to pick a variable, any letter that we choose to pick, and then state what words from the original problem that our variable represents. And you'll see that being done here on some of the problems that we're about to look at. Now, some helpful hints. The words is, or the past tense version of is was. Those words can mean the equal sign. But sometimes you're going to see the words is or was where it doesn't make sense for it to mean the equal sign. So you still have to think whenever you write your algebraic equation, does it make sense for me to have an equal sign at this spot or does it not? But that's just something to keep in mind. The word is, the word was, they might mean the equal sign depending on the context of where they are in the word problem. Some other helpful hints. Totals. We know in real life that when you find totals, you are often adding up things together to equal that total. However, if you buy multiple quantities of an item, each at the same price, then you can multiply the price times how many that you are actually buying. Speaking of multiplication, the words each, every, and also the word per can sometimes often mean that there's multiplication involved. Like if I work for $20 per hour and I want to find out how much money I'm going to make after 4 hours, I would take 20 times 4. That's an example of the word per. And the word each or every, they can do the same thing, where it would mean multiplication. Now, what I've given you here on the next part of your guided notes is a vocabulary review. This is not the first time you've seen this chart. We also saw this chart earlier this school year when we were kind of reviewing things at the very beginning of the school year. These are key words or phrases that have mathematical meaning. Now, you see I highlighted the one here for you where there's a number symbol and then followed by the word of. You're going to see this today on some of the word problems. Especially if there's a fraction. In fact, I even have an example here typed up for you in the chart. If I have the fraction of half or 1/2 followed by the word of, that actually mathematically means that you're going to take the fraction of half and then you're going to times by whatever comes next. It doesn't just have to be the fraction half. It could be 3/4. It could be 2/3. It could be some other oddball fractions like 7/11 or 8/15 or whatever the case may be. If you have a number, usually a fraction, followed by the word of, that actually will mathematically mean the fraction times whatever comes next. Now, don't forget about phrases like less than, fewer than, shorter than. Those phrases we know mean subtraction, as you see here in the chart. But when they have the word than, you must switch the order. And if you're not sure what I mean by that, take a look at this example. A $5 less than the payment, that phrase does not mean 5 minus p. You can see I have that crossed out for you. Instead, that phrase means the payment minus 5. So even though the phrase has the 5 on the left and the words payment on the right, you actually have to switch the order when you write it mathematically. That's just how the phrases less than, fewer than, and shorter than, that's how they work. All right, so let's take a look at some word problems. You can see here the directions are asking you to define the variable, then write an equation, and then we're going to use that equation to solve. And we're going to do that using the same skills that I've already taught you, and that is determining what's happening to the variable and doing the inverse of whatever is happening to the variable. Do the inverse operation of that on both sides. So first things first, let's read the entire problem, because that's what the key to success says we're going to do. We're going to read the entire problem, then we're going to define our variable, then we'll go back and translate piece by piece. So here we go. It says 7/9 of the cars on the road were sedans. This was equal to 224 sedans. How many cars were on the road? All right, now that we have read the entire problem, the next thing we're going to do is we are going to define the variable. Remember, that means we're going to pick a variable, any letter of our choice, and then we're going to state what words from the original problem that the letter that we picked actually represents. Now, there is a secret to this. Normally, a lot of word problems will have a question to them. Like on this one, how many cars were on the road? This is what they want you to solve for. So it makes sense then for us to pick our variable according to what the problem is asking us to find, because that variable stands for an unknown number. Well, what they're asking you to find is the unknown at this moment in time. So let's write down let C, and then you can draw an arrow or you can put an equal sign. I've seen it done both ways. And then let's use the exact same words that we see here in the problem. And that is how many cars were on the road. Or you can word it the number of cars on the road. You can say the amount of cars on the road. Any type of wording like that represents the unknown number of cars that happen to be on the road. And that's what we're asked to solve for. That is what our variable is going to represent. Now, since we have read the entire problem and we have defined our variable, as the key to success at the top of the page says, we're now going to go back and we're going to translate piece by piece, starting with the first sentence. If there's more than one sentence, then we'll obviously do the other sentences as well and translate. And our goal is to be able to take the words and the numbers in the problem and translate piece by piece to get our equation. So, for example, this problem starts by saying 7/9, and then it has the word of. We just learned from the chart that if you have a number followed by the word of, then it means that number followed by times. So, we're going to write 7/9, and then we can put a times dot. Although we might not need a times dot if the next thing is a variable. So what does the rest of the sentence says? Well, it says 7/9 of the cars on the road. Well, didn't we just say that the number of cars on the road is our variable C? Ah, we did. So that means we're going to take 7/9 of the C, 7/9 times the C. Well, you actually do not need a times dot when you have a fraction times a variable. So we're not even going to bother putting a times dot there. We'll just put the C next to the fraction, and that will mean multiplication. All right, there is a second sentence. Let's keep reading. This, the word this is referring back to the 7/9 of the cars on the road. This was equal to, well, I think we know right there that that phrase definitely means the equal sign. I told you earlier at the top of the page that the word was or is can often mean the equal sign. Well, it's pretty clear when it says was equal to, well, that's definitely your equal sign. And then what does it say after that? Well, it says 224 sedans. So since that's to the right of the phrase was equal to, we're going to put it to the right of the equal sign. In fact, you guys are going to find out as we do these problems, the order that we read the things from the sentences, we're going to keep it in that same order as we write our equation. That's the easiest way of using the power of translating piece by piece. Now, there is one time where the order has to switch, and we talked about that earlier. Less than, fewer than, shorter than. In those kind of two-word phrases with the word than, you will have to switch the order. But aside from that, it's going to stay in the same order as it was given to you in the sentences. All right, now that we have our equation, now we can go through the process of asking what's happening to the variable. I like to abbreviate that question off to the side, WHTTV, for what's happening to the variable. And then, after we know what's happening to the variable, we can do the inverse. So what's happening to the variable? Well, we already know if the 7/9 is next to our variable C, then that means it is being multiplied by the 7/9. What's the inverse? Well, the inverse of multiplication is to divide. So let's do this inverse underneath the equation on both sides. So let's write this down. Divide by 7/9, divide by 7/9. Now, if you would rather treat division of a fraction as multiplying by the reciprocal, there are also a lot of adults who know what I'm talking about. So if your parents are watching this video, they might be thinking about multiplying by 9/7. That actually means the same thing as dividing by 7/9. Since I'm going to allow you to use a calculator today, you don't really have to make it multiplying by 9/7. You could, but we can just keep it dividing by 7/9. Let's work down on both sides. On the left-hand side, we know anything divided by itself will give us 1. So this is going to give us 1c. Now, bring down your equal sign. Bring it straight down from where it was above. And now in your calculator, you can do 224 divided by 7/9. It's very important that you keep the 7/9 to the right of the division symbol. If you switch the order in your calculator, you will not get the correct answer. So that means you're going to have to enter the 224 into your calculator first, then hit the division key, and then 7/9. If you do that correctly, you should get the answer of 288. And now let's simplify the 1c, because that means 1 times c, and so that's going to give you the c by itself. Now, since this was a real-life scenario problem, it is very important that your real-life problem's answer is a real-life answer. So it's not just 288. Real-life answers are not just a number by themselves. It's a number of something. In this case, it's the number of cars. And if you ever forget what kind of unit of measure or label that you should put on your answer, you can always go back and reread what you defined your variable as, which went back to what the question was asking you to find. How many cars are on the road? So the answer is 288 cars. All right, let's look at another problem together. It says the -8-degree temperature was 22 degrees less than the temperature last week. What was the temperature last week? All right, first things first, we're going to define our variable. The last sentence is asking the question, and the question kind of refers to the type of thing you're supposed to solve for. This should be what you make your variable to be defined as. So let's pick the letter T. Now, if you choose T, put a little curl on the bottom going to the right, so that way it doesn't look like a plus sign. Let's say that we're going to let T represent the temperature last week, just like we read from the sentence. Now that we have defined our variable, let's go back and let's translate the problem piece by piece in the same order it was written, unless we see one of these phrases like we saw underneath the chart where we have to switch the order. All right, so the problem said the -8-degree temperature. Well, let's go ahead and write down -8. It says was 22 degrees less than the temperature last week. Okay, I'm getting a little ahead of myself here. The word was might mean the equal sign. If you're not sure, then maybe we can skip that for now. And let's maybe move on to the next part. 22 degrees less than. All right. We just learned that with less than, actually we didn't just learn this, we talked about this in the first chapter of the school year, that with the phrase less than, you have to switch the order. So we are not going to put 22 and then a minus. We're going to have to switch the order and have something minus the 22. Well, what is that something? Let's keep reading the words. 22 degrees less than what? Less than the temperature last week. Oh, that's our variable, isn't it? We said our variable was going to represent the temperature last week. So that's what's going to be on the left of the minus. All right, so let's go back to that blank spot that we have between the -8 and the T minus 22. Does that make sense now for the word was to mean the equal sign? Well, yes, it does. I mean, we have to have an equal sign somewhere when we're writing an equation. All equations must have an equal sign, so that is the logical spot for it to be. So that confirms that the word was definitely meant the equal sign on this problem. All right, now that we have our algebraic equation, we can answer the question, what's happening to the variable, and then do the inverse. So what's happening to our variable t? Well, it's being subtracted by 22. You can abbreviate as you answer this. What's the inverse of subtracting 22? Well, that would be adding by 22. We are going to do that on both sides of the equation. Now, before you work down, may I remind you that subtraction is the same as adding the opposite. Now that you have done that, Now you can go ahead and work down. The right-hand side has negative 22 plus 22. We know that's going to give us 0, because anytime you have a negative plus a positive and it's the same absolute value, when you subtract in your head, you will get 0. Now the t does not disappear. The t is still there. Bring down the equal sign straight below where it came from. How about negative 8 plus 22? Well, it's a negative plus a positive. You'll subtract in your head. 22 has the bigger absolute value. So that means the answer is going to stay positive. And then let's simplify this. T plus 0 is the same as just t. Bring that equal sign back down. Bring down the 14. And how did I know to put this degree symbol? Well, because T is the temperature last week. And we saw above, they never told us if it was degrees Fahrenheit or degrees Celsius. It just said negative 8 degrees at the very beginning of the first sentence. So that's why we're just going to say 14 degrees. We don't really know if it's Fahrenheit or Celsius, and that's okay. This is the unit of measure that answers our question. The temperature last week was 14 degrees. All right, at the top of the second page are 2 more word problems. The directions want you to circle the correct equation that could be used to solve the problem. So it doesn't actually ask you to do the solving. This is a test to see, not a real test, but this is where I want to see how well you can take the skills that we have learned, where you read an entire problem, then you go back and translate piece by piece, and if you do that, you should be able to come up with the equation and therefore choose the correct choice, A, B, C, or D. So I want you to do number 3 and also number 4. If you don't have your guided notes with you, you're going to have to pause the video when I actually show the word problems here and go ahead and try 3 and 4 on your own. So hit pause now, do 3 and 4, and then hit play when you're ready to see how you did. All right, I hope you have already made your selections for 3 and 4. If not, please hit pause right now before you go any further in this video, because I'm about to go ahead and go over their answers. So here we go, number 3. It starts by saying Penelope's age. Well, they never tell you her age, so we're going to pick the variable P. It says is, and I'm going to stop right there. As you read this problem, you should have realized the word is at this point in the sentence. It does make sense for the word is to be the equal sign. And then it says 18 years younger than. Younger than is like less than or fewer than or shorter than. And that's what I was talking about underneath the chart, how those phrases with the word than, you have to switch the order. It will mean subtraction, just like less than, fewer than, or shorter than would mean subtraction. Younger than works the exact same way. So it's not going to be 18 to the left of the minus. You have to switch the order anytime you have less than, fewer than, younger than, like we have on this problem. And then it says twice Sonia's age. Now, I didn't talk about this, but the word twice is found in the chart. If you look back, the word twice means 2 times something. So, you need to have 2 times whatever is next in the sentence. And the next thing in the sentence is the phrase Sonia's age. Well, we are never told what Sonia's age is, so that is going to be the variable S. And you can now see that choice D was the correct choice for this problem. All right, problem number 4. 66 tickets were purchased at the door. This was 3/11 of all the tickets sold. How many were sold? Let's take this piece by piece. It starts by saying 66, so you're going to write down 66. It says after that, this was. And as you read this problem, there was no other place that would make sense for the equal sign to show up. So this is one of those situations where the word was does mean the equal sign, because there's no other logical place, if you already read the rest of this problem, for the equal sign to show up. The next thing it says is 3/11. Well, we know 3/11 means 3/11. But then it says the word of. And we learned on the chart from the first page, I was already talking about this, that when you have a number followed by the word of, that means the number is times whatever is coming next. That same thing happened on number 1 with 7/9 of. So that's going to apply here on number 4. 3/11 of. But do you need to put a times dot? Well, it depends. What is next? The next thing was all the tickets sold. And then the last sentence literally asks how many were sold. So that is the unknown. We pick a variable, probably t. So it's 3/11 times t. You don't need a times dot to show a number times a variable. And so you can all see that choice B was the correct choice for this problem. All right, let's finish this video by doing 2 more problems together. We'll look at number 5, then we'll look at number 6. The directions, once again, are wanting us to define a variable, write an equation, and use it to solve the problem. So let's read all of number 5, then we'll come back and we'll do the other parts. Fred spent a total of $123. He bought 1 program for $15 and 6 tickets each for the same price. How much was each ticket? All right, the last question normally gives you the part you're supposed to solve for. We're trying to find out how much was each ticket. And the phrase how much is referring to the unknown price. You might remember it even talked about the price of each ticket being the same. So let's use that wording. P is a very logical choice because we're talking about the unknown price of each ticket. Now I was very picky here with how I worded this. The price of each ticket is not the price of all the tickets combined. It's the price of each individual ticket. That's what we're trying to find. That the words literally said that. Okay, now let's go back and let's translate piece by piece. Fred spent a total of $123. Well, we all know 123 means 123, so that's the very first thing that we should write down, since we're going to translate this piece by piece and keep things in the same order as they are written. The word total can sometimes mean you're going to add things together, so we're going to keep that in the back of our mind. We might have to eventually add, or maybe we're going to multiply, or maybe a little bit of both. So let's keep reading. He bought 1 program for $15. Well, we could write 1 times 15 because it's 1 program for $15, but I think we all know 1 times 15 is just 15. So let's just go ahead and write down 15. And 6 tickets. All right, we know 6 means the number 6. 6 tickets each for the same price. All right. The word each, we talked about this on the first page. It was in the chart. It was also showing up in the helpful hints. The word each, every, or per, that often means that multiplication is involved. And we also learned that if you buy multiple quantities of an item, you can each at the same price, you can multiply the price times how many you buy. And that's exactly what is happening here on problem number 5. We are going to take the number of tickets we're buying, which is 6, times the price that each of them happens to be. They're each at the same price. What is that same price? Well, that's our variable P. So 6 times P is what we need to write. Okay, we have some blank spots here. One of those blank spots has to be the equal sign. The other blank spot, well, what was this problem talking about? It was talking about Fred spending a total amount of money. And when you find totals in real life, you often will add things together. So what did Fred buy? He bought a program. He also bought tickets. We're going to add those things together to get the total. Well, then what's the only thing that makes sense to put here in this blank spot between the 123 and the 15? The only thing that makes sense is to put an equal sign. Now, this word problem did not have the word is or was coming after the $123 in that first sentence. We did not see the word is or was there. The word was does show up in the question, how much was each ticket, but that's just asking the question. So this is one of these problems where we didn't have the word is or was, meaning the equal sign. We instead had to figure out that the logical place to put the equal sign was right after the total of 123, because the $15 plus the money for the 6 tickets should add together to equal the total amount of money that we're going to spend. All right, let's go ahead and start answering what's happening to the variable. Now, since this problem has 2 things next to the variable, there are 2 things happening to the variable. It is first being multiplied by 6, so let's write that down, and then it is being added by 15. Yes, I can read backwards with multiplication and addition. You've heard of the commutative property. Order does not matter with multiplication. Order does not matter with addition. So I'm reading backwards, and the 2 things happening to the variable, multiplying by 6, adding by 15. What should be our first inverse? Well, as I've taught you in a previous lesson, the order for the inverse operations completely switches from what was happening to the variable. So we're going to start by subtracting by 15, and then later we'll do the inverse of multiplying by 6, which is to divide by 6. All right, I would love for you to hit pause on the video. You have done these kind of inverse operations before in a previous packet of guided notes or 2. So hit pause and start doing the inverse operations underneath on both sides. Then hit play when you're ready to see how you did. All right, I hope you have already solved this problem using inverse operations on both sides. If you haven't, you really need to hit pause. Do that on your own. All right, here we go. Did you subtract by 15 on both sides like we said we were going to? You could make the subtraction here adding the opposite, adding a negative, but there really is no need to. There are no negative numbers on the original equation. And I think we can easily take 123, which is positive, and subtract by 15 without having to make the subtracting by 15 become adding negative 15. So let's just go ahead and subtract. 123 take away 15 is 108. 15 take away 15 is 0. The 6 does not disappear, nor does the p, or the plus sign for that matter. So they stay. 0 plus 6p can simplify to just 6p. Additive identity property. Anything plus 0 is itself. Are we done? The answer is no. The variable is not by itself yet. Besides, we already said that there was a second inverse operation that we're going to have to do. So let's go ahead and do that now. Divide by 6 on both sides. That is going to give you 18 equals 1p, because 6 divided by 6 is 1. 108 divided by 6 is 18. 1 times p is the same as p. The unit of measure for this problem is going to be dollars, and that is because we were trying to find the price of each ticket. And if you remember, the units of measure for all the other prices on the original word problem was dollars. It wasn't euros or pesos or any other kind of currency. It was dollars. So that's why our answer is in dollars. All right, I'm actually going to save problem number 6 for the next video along with the rest of the guided notes. So thank you for watching. We'll see you next time.